Jai Hind everyone. I am Dr. Parul Verma from Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to deliver lecture on fuel, which is in Unit 4 in Engineering Chemistry. The code is BAS 102 and BAS 202. In this chapter, the following topics are there: classification of fuel, characteristic of fuel, analysis of coal, in which two topics are there: proximate analysis and ultimate analysis. Then determination of calorific value. There are two formulas by which we are going to determine calorific value. One is bomb calorimeter, another one is Dulong's formula. The last topic of this chapter is calculation of air needed for combustion. The book I referred for this topic is Engineering Chemistry by Jain and Jain, then Shashi Chawla, and Engineering Chemistry by Ville, India. In particular, this lecture I am going to cover topic definition of fuel, types of fuel, then properties of fuel, calorific values of fuel by using bomb calorimeter. The rest of the topics I will cover in next lecture. Now coming to the first topic, that define fuel. How we can define fuel? Any combustible substance which on burning in air produces large amount of heat is actually termed as fuel. This process of burning in which, for example, if carbon is there, its on burning provides CO2 and liberate lots of amount of heat. So any fuel is having lots of carbon constituent in it. Carbon when burns, it provides carbon dioxide and also liberates some amount of heat. It is also known as oxidation process. We can also say that combustion is the process of oxidation that provides heat. And we all know that we use this heat for various purposes, such as domestic purpose and industrial purpose. Some example of fuel which we can see everywhere in daily life, such as combustion of wood, petrol and kerosene, which provides heat energy. Now coming to classification of fuel. We can classify fuel by various methods. The popular one is that occurrence and how we can say that how we can prepare it. There are two categories of fuel. One is known as primary fuels. Another one is known as secondary fuel. Primary fuels are the fuels which we can take from environment as it is and which takes lots of years to form. Million of years are taken by the fuel to be formed, and it is referred as fossil fuel formed by the fossil substances. This is known as primary fuel. We use this fuel as it is. Secondary fuels are the fuels which we are deriving from the primary fuels. As we all know that energy cannot be formed, cannot be created, cannot be destroyed, but it can be converted. So energy of primary fuel will be converted into energy of secondary fuel. Example of secondary fuels are coke, gasoline, coal gas, producer gas. The next classification is, we can classify fuel into three categories: solid fuel, liquid fuel and gaseous fuel. As we all know that we are using all types of fuel in daily life for domestic purpose and industrial purpose. And we can also classify it as in terms of primary fuel and secondary fuel. Some example of solid fuels are wood, peat, lignite, all types of coal. Artificial fuel or secondary fuel and solid fuel are charcoal and coke. The example of liquid fuel is crude oil in case of primary fuel. And example of liquid fuel in case of secondary fuels are petrol, because we formed petrol by refining of substance, which is known as refining of petrol. So petrol is actually a secondary fuel and it is a liquid fuel. Next category is gaseous fuel. Gaseous fuel in which natural gas is there in terms of primary gas, which actually formed naturally in nature. And another example of secondary fuel, which is gaseous fuel and also comes in the category of secondary fuel, is coal gas, oil gas, biogas. Biogas is one of the very good example of secondary fuel and it is an example of gaseous fuel. Now coming to the point that how we can say that this fuel is good fuel, or we can say that what are the various characteristics of a good fuel. first and foremost characteristic, which is very important in case of fuel, is its calorific value. Fuel must have high calorific value. What do you mean by calorific value? Energy provided by burning 1 gram of fuel. Energy provided by burning 1 gram of fuel. So if we are going to do any reaction or any application, we need some amount of energy. So if the fuel is capable of providing that much amount of energy, then only we are going to use that fuel. Otherwise, we cannot use that fuel. So this is first and foremost important characteristic of a fuel, that it must have good calorific value. Another one is ignition temperature. The temperature which we need to start the burning process. So whenever we are going to burn a fuel, we need some temperature at which it gets started. Burning is getting started, which is known as ignition temperature. In short, we can say the temperature required to ignite a fuel is known as ignition temperature. So it is also the characteristic. But this ignition temperature must be moderate, not very high and not very low. If the ignition temperature is too low, the fire can cause. And if the ignition temperature is too high, lots of energy get wasted in starting of the burning. When we are going to start burning process, lots of amount of energy is getting wasted to get the ignition temperature. Another important point is low moisture content. So if there are huge amount of moisture content in the fuel, the amount of fuel, the weight of fuel get increased and it decreases the efficiency of the fuel, because moisture is not going to burn at all. H2O cannot react with oxygen further and form combustible product. So moisture increases the amount of fuel, the weight of fuel, but it is not going to provide any efficiency or any calorific value to the fuel. Another important point is low non-combustible matter content. All material must be combustible in a fuel. For example, if the coal is having ash in it, this ash is completely non-combustible in nature. So when we are burning fuel, this ash is not going to show any combustion reaction and it is not going to provide any amount of energy. So the higher the amount of ash, lower will be the efficiency of the fuel and higher will be the weight of fuel. Next one is moderate rate of combustion. The rate of combustion must be moderate, because if it is too slow, the reaction proceed at very slow speed. The application, we cannot do the application properly. And if it is very high, we cannot control it. If the rate of combustion is very high, we cannot control it. Next is minimum smoke and non-poisonous gases. So nowadays it is a very important factor, as you all know that AQI is rising day by day. So the fuel must be like that it liberates minimum amount of smoke and almost zero non-poisonous gases. The fuel must be cheap enough so that we can use in a particular application and it will not increase the cost of a product. Easy transportable, the fuel must be easy transportable. Combustion can be controllable. Combustion should be controlled in an easy manner, then only the fuel is useful for us. The combustion process should be non-spontaneous and the storage cost must also be low. So these are the various characteristics of a fuel, of a good fuel, due to which after studying these characteristics, we can actually choose the fuel for our practical purpose. So these characteristics can be classified on the basis of its state of matter, the state of matter of a fuel. For example, cost. If we are taking the characteristics such as cost. So we can say in rural areas we are using solid fuel till date. Why? Because the cost is low. Solid fuels are cheap. That's why the people who cannot afford heavy fuels, costly fuels, they are using coal. Although it produces smoke, it is having lots of amount of ash, but due to its low cost and due to easy in storage. Till date, we are using solid fuel. We are somehow depending upon solid fuel. Especially in rural areas, the people are depending upon solid fuels. Next one is, on the basis of cost, liquid fuels are costlier than solid fuel, but gaseous fuel are costly than liquid fuel and solid fuels. When come to storage, solid fuels are easy to store. We can store anywhere in a container, anywhere we can store it. In liquid fuel, at least we need a container to properly container. A proper container is needed for storing the liquid fuel. In case of gaseous fuel, huge storage space is required with a proper piston. It means the storage space must be huge and it should be leak proof. Next important characteristic, risk towards fire hazard. Solid fuels are having less risk of having fire hazard. It is having more risk, and the risk in case of gaseous fuel is very, very high. Now coming to combustion rate, as you all know that solid fuels burn very slowly. It means the rate of combustion, the reaction rate is low. The rate of combustion is very slow in case of solid fuel. In case of liquid fuel, it is a fast process. In case of gaseous fuel, this process is very rapid and efficient. Now coming to combustion control. This is a drawback of solid fuel, that the combustion of solid fuel, when it getting combust, it cannot be controlled easily because we are not having any piston or regulation that we can stop it after burning get start. Liquid fuel cannot be controlled very easily or stopped, but gaseous fuel can be controlled by regulating the supply of air. So if we close the burner, if we close the switch of the burner, the air supply will stop and gaseous fuel immediately switch off. Gaseous fuel does not burn now. So in case of combustion control, gaseous fuel are best fuel as per this particular parameter, combustion control. Next one is handling cost. As solid fuels are heavy, we need to give some handling cost for transportation. Labor is required because the fuel is so much heavy. In case of liquid fuel, somewhat low transportation cost is getting, because it can be passed through pipes, it can be flow through pipes. In gaseous fuel, similarly to the liquid fuel, the gases can be passed through pipelines, and once the system get installed in case of liquid fuel and gaseous fuel, the cost of transportation is low, or we can say negligible. But at the time of installation, when the system is getting installed, the fuel takes some handling cost, or we can say installation cost. If we take another parameter such as ash, in case of solid fuel, lot of ash is there, which can be a problematic. No problem of ash and no problem of ash in case of liquid and gaseous fuel. So this is the drawback of using solid fuel. Another drawback of using solid fuel is smoke. Solid fuel produced smoke in a very high amount. Liquid fuel are cleaner fuel, and because it is in this high carbon and aromatic fuels are there, which when burns, it forms combustible products such as CO2 and H2O, and no such pollution is there. But if liquid fuels are burned with the smoke of NO2 and SO2, it will provide pollutant. And in gaseous fuel, no smoke is produced. When we come to another parameter, calorific value. Calorific value is least in case of solid fuel. It is high in case of liquid fuel, and it is highest in case of gaseous fuel. If we talk about heat efficiency, in case of solid fuel, the heat efficiency is least. It means we need to burn a lot of amount of solid fuel to get the similar energy when we are going, as compare when we are going to burn liquid fuel or gaseous fuel. Now coming to the important topic of this chapter, that is calorific value. The calorific value of the fuel is defined as quantity of heat liberated either in kilo or in kilocalorie by burning a particular burning unit mass or unit weight of fuel. For example, if carbon reacts with oxygen and form CO2 and provide heat, and if we take 1 gram of carbon in this reaction particularly, it takes 1 gram weight of carbon. It means 12 gram in case of molar mass, 32 gram of oxygen, 12 gram of carbon reacts with 32 gram of oxygen and provide 42 gram of carbon dioxide, and some heat is liberated. On burning 1 mole of carbon, 44 gram of CO2 is produced and heat is produced. By burning 1 gram of carbon, the amount of total heat, or we can say energy, which is provided by the fuel is known as calorific value. It means when we burn a fuel, it gives some amount of energy, and because we are going to calculate this amount, which is known as calorific value, so it is the amount or quantity of heat provided by burning 1 gram of fuel, unit weight of fuel. And this is the molar equation of a fuel. Any combustible substance can be written in this molar form also, that 12 gram of carbon reacts with 32 gram of oxygen and produces 44 gram of carbon dioxide. What is the benefit of this calculation? That we can calculate that amount of, if we have 1 kg of carbon, that how much amount of heat will be produced by 1 kg of carbon. There are some general unit of calorific value in which we are calculating. First one is calorie, a very common unit. The energy needed to raise the temperature of 1 gram of water by 1 degree centigrade is known as calorie. And we all know that 1 calorie is 4.2 joule. Another unit is kilocalorie. It is a unit of energy of 1000 calories. Next is British thermal unit. It is a traditional unit of energy equal to about 1055 joule. It is the amount of energy needed to cool or heat 1 pound of water by 1 degree Fahrenheit. 1 pound of water by 1 degree Fahrenheit. So the value become that 1 BTHU means British thermal unit is equal to 252 calories. This is the unit by which we can convert the calorific value into another unit. The next unit is centigrade heat unit. It is the quantity of heat required to raise the temperature of 1 pound of water through 1 degree centigrade. 1 pound of water through 1 degree centigrade. Although the British thermal unit is to raise the temperature of 1 pound of water through 1 degree Fahrenheit. And 1 kilocalorie is equivalent to 3.968 BTHU, that is equivalent to 2.2 CHU. 2.2 CHU. So why we are studying these units? Because we are going to use fuel for industrial purpose, and because we are going to use fuel for industrial purpose, we are actually need these kind of units wherever we are going to use such kind of fuels. The common units for calculating calorific value is calorie, kilocalorie and joule. The common units are these. Now, coming to the next important point, that there are 2 types of calorific value: gross calorific value and net calorific value. What is the difference between gross calorific value and net calorific value? Gross calorific value is also known as higher calorific value. Net calorific value is also known as lower calorific value. It is known as LCV or NCV, lower calorific value, and net calorific value. It is known as GCV or HCV, higher calorific value or gross calorific value. So what is the difference in these calorific value? Whenever we are heating the fuel in a particular container such as bomb calorimeter with proper arrangement where high amount of pressure and high amount of temperature can be maintained. So wherever high amount of pressure can be maintained, the amount of energy liberated by a fuel is known as gross calorific value. And whenever we are burning the fuel and we are not allow the vapors to getting escape, we are not allowing the vapor to get escape, although the vapor formed after combustion are condensed in the sample. So if we are heating the fuel in an open container, in particular bomb calorimeter, we can take example that we are heating the fuel in a bomb calorimeter under high pressure and high temperature. The fuel is getting vaporized and it is having one lid. The vapors which are forming during this process is getting condensed. It means it is not allowed to escape. The vapors are not allowed to escape. This fuel, this time, the fuel is going to give the maximum amount of energy it can provide. It is known as higher calorific value. So we can say the amount of energy provided by the fuel when the vapors are not allowed to escape. And when the vapors are allowed to escape, it is known as lower calorific value. Here the vapors are allowed to escape. It means we are burning fuel in a particular application, we can say, not in an experiment, but the vapors are allowed to escape. So when the vapors are allowed to escape, it is known as lower calorific value and net calorific value. Both calorific values are equally important for practical purposes. Higher calorific value we can calculate because if we have calculated the higher calorific value, we know that this is the maximum amount of heat that fuel can provide. And lower calorific value is the value of energy given by the fuel which we can use in application purpose. So both the values are equally important and we are going to calculate both. Gross calorific value is the value when the vapors are not allowed to escape. It means the heat of vapor, the energy provided by the formation of vapor are also included in this. While in lower calorific value, it is not included. If the vapors are getting escaped, it means it is having only the value other than the vapor formed, the value of energy other than the energy provided by the vapor formation. This is known as lower calorific value. So, concluding that today we have studied the definition of fuel, types of fuel, and then what are the various characteristics of a good fuel. Then we have classified these characteristics in terms of solid fuel, liquid fuel and gaseous fuel. And we studied one important parameter, that is calorific value of a fuel. In next lecture, we are going to get that how we are going to determine these calorific value by different formulas. Thank you very much.